Everybody's here to learn about shipping your first Python package, which is awesome. And our speaker for today is Chris Wilcox, who's come all the way over from Seattle. So let's actually give him a huge round of applause for just making the trip. And just a bit more context, Chris is a developer at Google, and he's been working on the Google Cloud Platform client for ages. And I think Chris has actually got his own intro slides, so he'll do a much better job than me. But one more round of applause, everybody, and enjoy the talk.
Right, good morning, everyone. I gave a very similar talk at PyCon US, and when I got here, I found that some weird things had happened. So I figured we had to rework it a little bit. And so that looks a lot better. Welcome to my talk. This is Shipping Your First Python Package, Australia Edition. So a bit about me. As I said earlier, I'm from Seattle, which is way over there. There's a lot of ocean in between us. There's a few things you might know about Seattle. We like coffee quite a bit. That's probably a lot in common with people from Australia. We also have a lot of really good mountains and hiking and forests, and so that's what I do with a lot of my spare time. Another thing you've probably heard about Seattle is it rains all the time. This isn't entirely true, judging by the picture directly to its right, but it seemed like a logical place to put a bunch of cloudy things, and so that's what brings me there. I work for Google in Seattle, particularly on the client libraries. So at this point, I focus on 7 languages, but I'm a Python expert myself. Otherwise, do a lot of Node stuff. When I'm not doing those things, I have an enjoyment for things that are two-wheeled. So if you want to talk about things that aren't technological, this is probably a good subject. So what are we going to talk about today? We're going to talk about how we can make you a Python package maintainer. We're going to have you publishing your own packages probably about the end of the first 5 minutes of this talk. We're going to discuss some of the features that exist with PyPI and Setup.py. We're also going to talk about ways you can automate this. So after this talk, you don't do most of what I talk about ever again. So let's start by talking about the Python package index and what this is. PyPI is known by a bunch of different names. Originally it was called the cheese shop. Now by most of the maintainers, we think of it as a thing called warehouse. This is what makes Python a great language. All of the packages we have available to us allow us to make applications and worry about our business and our concerns, and not things that we're less interested in. This ecosystem has changed over time, though, along with Python. And so every few years, we sort of need to re-give a talk on how is it that you publish to PyPI. By the end of this talk, with any luck, there'll be no mystery around how to do this. You'll feel prepared to add your work, and you'll help grow the ecosystem. The package we're going to be using today is very simple. It has a single method that returns a static return. And we're just going to use this to demonstrate how you would package something. So we're not going to focus too much on the Python code itself. We're going to focus on setup.py, setup.cfg, etc. So the first thing we're going to do is we're going to make a setup.py file. What's on screen right now is all that's required of you in your code base to publish to PyPI. You need to specify a name for your package, a version, a brief description of what this does, and you need to specify what modules it includes. In this case, we call setup tools.findPackages, which will automatically do that for us. So you don't necessarily have to specify everything. You can do that if you'd like. So now that we've done that, the next thing we should do is test our code because we're responsible software developers. And how we're going to do this, we're going to go ahead and make a virtual environment. We're going to source it, and we can install. So pip install -e dot will install the local directory as a module, and the -e specifies editable. As a package maintainer, this is very helpful because it means you don't have to keep uninstalling and reinstalling the package as you make edits. And you can see below, we can start a Python REPL, import our package, and sure enough, it works. Cool. Next, we need to upload to testpi. You could go directly to production, but that's probably a bad idea. Testpi allows us to try things out in a way that's not risky. If we make a typo or any sort of mistake, no one has to see it. And so we're going to start by installing 2 tools. Twine, which we use for uploading, and Wheel, which we use so we can build binary distributions. Next, we're going to run Python, setup.py, sdist, and bdist wheel. This is going to create a source distribution. This works fine if you have just Python in your code base. We're also going to do bdist wheel. This is important if you start to rely on C extensions. This way your users don't have to have a compiler toolchain. You have it, you can build it, ship it to them. Makes it a lot easier. Next, we can run twine upload, and there's a repository flag where we can specify testpi. And everything that we built earlier with the command above is in the dist directory. So we specify that with a glob pattern, and it all gets uploaded. Once we've done that, we can install from pip, specifying an index URL for the testpi endpoint, and verify that our package uploaded and installs correctly. This is rather important, since earlier when you did the editable install, if you didn't include something, there's a possibility that the package worked despite something not getting packaged. And so it's very good to do this testing at multiple points. So now that we've done that, we can create an account on pypi.org. We can run the same two commands we ran for testpi, this time specifying the pypi endpoint instead. And we've published a package. We can install it the way we install any other package, and we're done. Congratulations, you came to my talk, you did it. You're all done. Woo! Okay, so for those aware in the room, that's been about 5 minutes. There's probably a bit more, right? You don't want to do this. What I just had you do created a very bare bones package. It tells your users very little about what your package does, what it supports. That brief description that said a test package probably isn't very helpful. It might not even look legitimate to people. And honestly, no one in this room has ever in their life thought the bare minimum was a good idea. So the first thing we're going to do before I get any further is talk about not using setup.py. There are multiple ways, like I said earlier, to do things to get to PyPI. Setup.cfg is one of them. So rather than doing things inside setup.py, which is a Python script you can run, we can do it in a configuration file. This is very much the same. The biggest difference being there'll be less quotes. You won't have errors because you missed a comma somewhere. And so it ends up being configuration-based. Otherwise, it's very similar. So here, you can see that it's changed around a little bit. You can see that find packages is now just find : but otherwise, it looks basically the same. If you want to see how to do this with setup.py, the talk version I gave in PyCon US has that, and the recording's on YouTube. So if you want to compare, you can do that after. And now that we've done that, setup.py is a very small script that's likely never to change. It has a main method that runs setup with no arguments, and this will rely on setup.cfg from now on. So I brought up that this is a bare minimum package, and I sort of lied a little bit. If you ran the command I showed earlier, you'd get a bunch of warnings saying that you probably want to have authors, author information, an URL for the project. None of this is required by PyPI. You can upload the package and ignore these warnings if you'd like. But there's probably a reason it gives them to you. They're helpful for your users, and it gives confidence that this is a legitimate package. So we're going to start by adding those things. We're going to specify author. We're going to specify author email. And we're going to specify an URL to the project. The next thing that we want to add are classifiers, sometimes called troves, depending on who you're talking to and what documentation you're reading. There are currently around 600 of these that allow you to specify more exactly what your package does, what it supports, if there's a sub-language community, if there's an OS restriction. And so for our package, I've started with a basic list. We have an alpha status, because this is the first time I've done this. I'm not sure it's going to work yet. Use with caution. I specify a license, the different versions of Python I'm going to support, which are the currently supported versions of Python 3. The operating system is independent. I've done nothing that would make me believe this can't work on any operating system. And I think it's a utility. I think the most important classifier, though, is license. And there's an additional license field you can set in addition to the classifier I set for Apache. There's a problem with unlicensed software. Occasionally, people think unlicensed means a free-for-all, do what you want. But to the professional or the business involved, it's exactly the opposite. It's a giant red flag. I don't know what you're going to allow me to do. I need to know what I am allowed to do with your code. So please license your things. It makes it a lot easier for people. There's agreed upon ways to do this. There are about 80 different classifiers for licenses, so I'm not going to try to list them. But the usual suspects are there: Apache, GPL, MIT, and more. And so for this, I'm going to use Apache 2.0. That's what we use for most of our Google Cloud libraries. And so I specify the license equals in addition to the classifier. The other thing we want to do is provide a longer description. That short description is nice to sort of get a blurb, but the longer description allows us to do things like include code samples or how to file bugs. For most people, these tend to be the readmes they include on GitHub. Multiple formats are supported today. You can do this in plain text. You can do this in Markdown. You can do this in restructured text. And you can do this in Common Mark. So here, I specified Markdown. A common error is to leave off the content type. If you do that, it will just assume that it is plain text, and that's probably not what you want. So for Markdown, we specify Markdown. This is also a good time to mention why setup.cfg is kind of nice. If we were to have done this on setup.py, the lower code fragment would have been used. We have to open the file, and we have to read it into the variable ourselves, and that leaves us open to make mistakes. Where the top version is all we need to do here, uses a configuration, we can just say that is a file, and then setup tools will handle it for us. Another thing is specifying specific Python versions that are allowed to be used. So classifiers are advisory. They aren't restrictions. They don't stop users from doing anything. So if you want to enforce that someone doesn't use your code on, say, Python 2.7, which you've never tested your code on before in your life, and you don't want to deal with the bugs that will eventually show up, this is a handy way to stop that. So for my package, I've created it today. I don't want to support old runtimes or runtimes that will be gone very shortly. So I'm going to support 3.5 forward, so all of the currently maintained versions of Python. This will prevent us from getting issues we don't care about. It'll stop our users from going places we didn't intend them to go. And so this can be very helpful. Another thing that's really common is that we'll ourselves, as packages, have requirements and dependencies. And so you might need to specify those. So just sort of as an illustration, here's how you would include urlib3 and requests as dependencies to your package. So that's it. When you're done with this, you have a package that has a bit more configuration than we originally started with, but it now looks like a complete, trustworthy PyPI package that your users would be happy to take and use for their own systems. So let's move on to some of the other things that I breezed over. In order to upload, you have to use some form of authentication. There are a lot of ways to do this today. Here are 3 really popular ways. I would say the most popular way is to manually enter it. So use your favorite password manager and store your credentials. Whenever you need to upload, you just copy, paste it in from that password manager. Everything works all right. There's also a plain text file you can use called PyPIRC to store this long term. The hazard being that it's plain text, and it's on your hard drive on some development machine somewhere probably, and that might not be a risk you want to take. It's not terrible, but there's a chance someone else gets that file. They tend to go into common places. The other option is to use a thing called keyring. Keyring also stores things in plain text by default, but it does support encrypted backends if you'd like, and so you can encrypt it, for instance, on Mac to use your operating system password and prompt you. But by default, that's also plain text. And so putting your password for all of PyPI also might seem risky. Lucky for us, very, very recently, beta support was added for API tokens. So on PyPI now, you can specify that you want an API token for one of your projects instead of all of them. In the case of me, I have about 4 dozen unique projects, so it's nice to be able to scope things down. And so I can say, in this case, I'm showing I'm only going to give access to Knox for uploading this package. So now even if I store this in plain text, the worst thing someone could do is upload a new version of Knox. They can't change my account password on me. They can't upload other packages. And so this is something that at this point I would recommend using. Like I said, it's in beta, and so you use with care. But it's definitely the future way that I would recommend managing your credentials. So I'm hoping at this point there's someone in the audience thinking this exact statement. You know, there's a lot of moving parts going on. The slides will be available, so you can obviously reflect on them. But there are also a lot of other helpful resources. First of all, on the PyPA, there's a GitHub repository called Sample Project. And this includes a fairly fleshed out version of what a setup.py would look like. A lot of different examples of how you might fill in those fields. And so this can be really helpful. Another common thing that I don't use, but a lot of people do, is Cookie Cutter. Cookie Cutter is a template engine, a templating tool that you can use to create a new project. And it will, by default, ask you a bunch of questions about what is your name, what is your email, what is this project. And then it will auto-populate setup.py for you, as well as some testing frameworks, et cetera. So if you haven't heard of Cookie Cutter before, I'd recommend looking into it. It's a very powerful tool. Like I said, it's not for everyone, but a lot of people find this helpful. I personally use existing projects I have. So as you continue to do this and create your own projects, your own setup.cfgs, you might find, as I have, that it's useful to just copy and paste one of those, change the few things that do change between projects, which tend to be the description, the name of the project, the version number, and then move on. So kind of choose your own way to do that. So now that we've done that, the obvious thing is to make sure we can avoid doing most of this work ever again. And so we can do that by automating things. So there are a few reasons we'd automate. First of all, the big stink I made about credentials being on your machine, that's no longer a problem. If you start automating this, those credentials will only live in CI. And I trust that most CI systems are better at managing secrets than I am. You also ensure that every time you publish, it happens the same way. This means one time you don't accidentally not type beatist wheel and ship a new version that doesn't have binaries. This also makes it far easier to scale your team. So when you're an individual owning a package, it's really easy to do this from your dev box. But as your team grows to more than one person, that just doesn't work anymore. And you probably don't want to have to hand out that API token to every single maintainer of the project. So to do this, we're going to talk about using some automation tools. The most common tool in the Python ecosystem right now is Tox. Tox is a configuration-based automation tool that allows you to have jobs that run particular versions of Python with particular dependencies. It allows it to display them, so you can specify a single job that can run 2.7, 3.4, 3.5, et cetera. And this is very useful for package maintainers. So when you run a website, like a Flask app, you only have one runtime that you need to target. But once you ship packages, you don't really know what runtime your users are going to use. So this ability to spread out and try the multiple different versions is very helpful. Another tool is called Nox. And this is a project that I contribute to and a coworker of mine started. It's very much like Tox, which you could probably guess by the name. The difference being that much like the difference between setup.cfg and setup.py, this one is based on Python scripts. So it uses Python decorators to do the displaying, and it uses Python functions to be the jobs. So it's very similar, but it's also very, very flexible. Because you're in a Python script, you can do just about anything you want. So because lots of Tox exist on Tox, I'm going to walk through Nox. But all of these things could also be done using Tox if you'd like. Tox has really good documentation. So let's start by talking about unit testing. Here's an example of how we'd run unit tests across the 3 versions of Python 3 that are currently supported. We start by installing the mock framework as well as PyTest, installing our extension, our package, excuse me. And then we can run a session. In this case, we're going to run PyTest. We tell it where the tests are. And we've also allowed ourselves to provide positional arguments if we want to from the command console. Pretty straightforward. It's not really different than how you'd run PyTest. So if you were to run PyTest manually, type PyTest -- quiet. Now you just type Nox -s unit and the same arguments you would give to PyTest. What's nice about this, though, is you can do more than PyTest. By using something like Nox or Tox, we can also build our documentation. So here, I can install Sphinx. I can tell it to run Sphinx build. And now we can generate our documentation. So part of CI, or just before we even open a PR, we can make sure that our edits to the code base will still allow the docs to build. So that's a pretty basic understanding of how you might use Nox or Tox. So now let's talk about CI. I'm going to talk a bit about how to use Circle. There's really no reason I chose Circle over something like Travis, Azure Pipelines, or any of the other things you could use for CI. But Circle CI is one of the more common ones. And it's one that I have used in the past. Nice thing is you can just sign in using your GitHub credentials and then start making a project. So once you do that, it'll already know about your existing GitHub repositories. This also works for Bitbucket. So here's our GitHub repository. And it has some basic setup for us. It tells us how to create a folder to include our configurations for Circle. And it tells us how we can go about updating a config.yaml file. It also includes a useful sample at the bottom. This is more useful if you're doing something like Flask or Django, though, than a package. That's what they tend to target this for. So you can start from theirs, but you might have to make a few more edits than you'd like. If you're interested in something more targeted for a library, I'll have a link at the end to my GitHub project that I used to make this talk, and it might be a better starting place. So what goes into config.yaml? The first thing we have to do is we have to specify workflows. The workflow I'm going to start by specifying is about how we might build and deploy, since that's mostly what we want to do. And so we can specify different test jobs. In this case, I've specified 3 unique test jobs, 1 for each version of Python. And I've told it that it should build on the tags. We also tell it how to deploy. So the deploy job has a dependency that the test 3.7 job passes. I could also make it depend on all of them. But in this case, I'm assuming if the 3.7 job passes, and the other stuff didn't fail earlier while we were making the commits to change the code base, it'll all be fine. And it ignores anything happening on branches. And that's kind of just to make sure that we don't have maintainers accidentally triggering a release of the project. So what do these jobs look like? A Circle CI job contains parameters that it can take. It contains a Docker image it uses, and it contains steps. So we start by checking out the repository, and then doing very similar things that we did earlier in the talk. We install some basic requirements to run our test jobs. In this case, we just install Nox, because Nox itself is going to manage the rest of the dependencies for us. And then in order to run it, we activate our virtual environment and call Nox. So whenever you don't specify anything else to Nox, it will run all possible permutations. So by default, this job is going to run all 3 versions of our unit tests and the docs build. And then we can add a deploy job. Very, very similar to the previous job. The biggest difference is being now we're going to install Twine and Wheel. We're going to add setup.py builds, and we're going to upload via Twine. And now that we've done that, all we need to do to publish is change the version within setup.config, make a release on GitHub, and upon doing this and creating the tag, it's going to create a Circle CI job, it's going to build, and once it finishes, it's going to publish a new version. So just like that, we have set up an automated pipeline for publishing new packages to PyPI. So with any luck, there's no mystery remaining. You know how to do this, and I've created a few more maintainers. Thanks, everyone. And also, if you come to the front, I have a few stickers. In the middle one's special. If by the end of the conference here, in the first day of sprints, you manage to get something in to Warehouse, both myself and Dustin, my coworker, have some fun stickers that we can give you for becoming a contributor.
Awesome. So thanks so much, Chris, for your talk today. And here's a mug from the organizers and one more round of applause. And though I don't think we're going to be taking questions right now, I think Chris did welcome questions either at the front or in the hall. And we've got a little bit of time.